Hi, this is Rick for EDU Mobile, and now we are talking about properties. All right, some detail about classes and structures and enumerations. Anything that can have a property we're going to talk about now. So here we go. The first thing I'm going to say is prior to Beta 4, Swift did not have access control specifiers. After Beta 4, there are access control specifiers, and here's how they work. There are three: private, internal, and public. Okay, so for properties and for methods, we can declare private, internal, or public. First of all, I want to say by default, they're all internal. Now let's talk about what they are. Private means that this property or method is available only in the source file. Source file, not class, not structure, not enumeration, the source file where the entity is declared. Now, what does this mean? Well, in Swift applications, normally, like Objective-C applications, we have one file per class. But we might have many structures in a class. We might have many enumerations in a class, or in a file. And we also might have many classes defined in a file. So private is private to the file, not private to the entity in which it's defined. Of course, now, the other wrinkle to that is, if you're working in a playground and trying to see if something is private or really private and trying to test out your class, what's going to happen? Well, outside the class, you're going to be able to access that private property. And so you need to test private and public, you need to work within the context of an actual Swift file in a project. So private is private to the file. Internal is available within the entire scope of the app, all across your app. So if you declare something to be internal, it's available every place in your application. And that's pretty broad. In fact, you might think that that's the broadest kind of scope we could have, possibly. Well, you would be wrong. There's one more broader scope, and that is public. If you define something as public, it's available to your app or your framework that you have designed, and it's also available to anyone that imports the module where that is declared. So for example, you have a modular application that has many different modules, many different apps inside it, or you write a framework and you want to expose that framework to the public for them to use. Then a lot of things that you would want to declare would be public, and those would be the things in your framework that you expose in your API. So public is for APIs, and essentially. Internal is app-wide, and private is only in this file. The default behavior, again, is internal. All right, so now that we've got that out of the way, let's talk about properties. First of all, there's two fundamental kinds of property. There are stored properties and there are computed properties. Stored properties are only used in structs and classes. So what's a stored property? Well, as its name implied, these are properties. These are constants or variables, but their value is stored along with the instance in which they're defined. That's all. That's all they are. So they go with the thing that they're in. An instance stored property belongs to the instance, and it's stored with the instance. It's there. A default value can be given to a stored property when it's defined. So let myProp equal 15, or let var myProp equal 15, whatever. If a default value is not assigned, the type of the property must be specified. Let myProp as an int, or let your prop as a float, or however you want to do that. So if you don't have an assignment, the type has to be specified. We already know that. That's true of constants and variables in general. An unassigned let stored property. Let's talk about what we're talking about here. A stored property that is a constant that is unassigned must be assigned during initialization. Okay, so when we talked about classes and structures, we talked about initialization. What does this imply? Well, if we have an unassigned let stored property, actually, if we have an unassigned var, you can get rid of that let word there anyway. If we have an unassigned stored property, we have to assign it during initialization. The default initializer doesn't assign anything. Essentially, it doesn't do anything. It just, initializes the class, gets it ready. So this implies that we must have our own initializer, and that initializer must initialize any unassigned stored properties. Okay. We'll talk about that again a little bit later. So now what happens if a stored property's value doesn't need to be known until the first time it's used? If that's the case, we can mark it at lazy. This is lazy instantiation, the same lazy instantiation that we used in Objective-C, the same kind of lazy instantiation we used in any object-oriented language. We're just giving it the name at lazy. So now we can mark a property to be lazily instantiated. At lazy properties, or lazy properties, must be vars. A let can't be lazy. Why? Because a let either has to be assigned when you create it or assigned in the initializer. It's going to be assigned regardless, so you can't make a lazy let. Lazies are often used, in fact, most often used, to avoid instantiating a reference type unless and until it's needed. And this would be like when a controller instantiates a model. We use lazy instantiation to do that. We don't need it until we need it. So don't do it until just in time. So instantiation of a lazy var is deferred until that var's getter is called, until the var is called upon. And then it gets instantiated. So let's look at that. Here's a class, a couple of classes. I want to look at the class data. First of all, we have a class data viewer that class data instantiates. So data viewer, we're not going to look at what it really is, but the idea is that data viewer formats and displays data for us. And it's a hideously big class that we don't want to instantiate at all if we don't have to. In class data, we do other stuff with that data. We might calculate values, but we also want to expose a data viewer just in case something that uses class data wants to view the data in some way. So we mark that lazy. What that means is lazy or dviewer won't be instantiated unless someone needs it. Otherwise, it would have to be instantiated. If it weren't lazy, it would have to be instantiated where? In initializer. So you're starting to get the idea. There's also a function viewData that uses that dviewer. So then later, somewhere in our application, we can say let my data equal data. Is it instantiated now? Yes, data is, but dviewer is not. It's only when we say something like mydata.viewData and then viewData causes dviewer to be instantiated, because that's what function viewData does. So this is lazy instantiation. We will see many examples of this kind of behavior. So are there ivars with stored properties? No, there are not. In Swift, stored properties are not backed by any sort of instance variable at all. There is no way, in fact, to create an instance variable that backs a property. So if you want to do that, forget it. You are always accessing your properties through getters and setters. You can never directly assign a property. Even though it looks like you might be doing that, you're not. Even if the property, the getters and setters are not explicitly defined, you're still using them because Swift provides them. So there is no idea in Swift of an instance variable. All right, we talked about stored properties, pretty straightforward. They're stored along with the instance. What are computed properties? Well, a computed property is not stored along with the instance. A computed property is a property basically that we can compute from the values of other properties. We only need it when we need it, but we don't need to store it. That's the idea. Now, computed properties can belong to enumerations and structures and classes. Everything that is an instance, let's say. Computed properties are not stored again. A computed property provides a getter, at least. It may also provide a setter, but at least it provides a getter that returns a computed value based on the values of one or more stored properties. Okay, pretty simple. Computed properties can provide a setter, and I'm going to talk about that a lot later, but all computed properties, pretty obviously if you think about it, all computed properties must be vars. Why? Because they're being computed, and they may probably be changed. One time you compute it, next time you compute it, and you get what? A different value. And if you get a different value, it is variable, not constant. There are also type properties, just as there are type methods, which we haven't really talked about yet. There are type properties. Now, type properties are like class methods, except they're types. In Objective-C, remember, we have class methods. If we wanted a property that belonged to the class object instead of an instance, we had to declare it static, number one, and we had to declare it as a C variable outside the definition or the implementation of our class. Remember that? Well, here they're folded into the idea of a class or a structure. So, what are they? Type properties belong to the type in which they're declared, not to any particular instance of that type. How do we access them? We use the dot operator, but we use the type name, not an instance name of that type. We still use the static keyword. Static says it belongs to the type, not to an instance. So we could have static var instance count equals 0. And then every time this guy was instantiated, we could bump the instance count. And the idea of there being we would know how many instances were floating out there. If we didn't have automatic reference counting, that might be a good idea, but it's just an example. Stored type properties must always be assigned a value in their declaration. They can't be assigned a value in their initializer, because an initializer is an instance method, and it can't get to the type property. So when we store a type property, we must assign it a value. Now, if we have a computed type property, it has to compute a value for itself. And this uses a different syntax than a computed instance property where we define a getter. So we have a type property, static, some computed value, and then we just say equal and then curly braces and we compute the value. Type properties can't get to instance properties. Type properties can't get to instance methods, but type methods and type properties play very well together. Okay, let's go on. When the value of a property changes, we can observe that change. There are two observers for properties, or property observers, and they are called willSet and didSet. If they are defined, they're going to be called every time a stored property's value is set, even if the value doesn't change by that set operation. The only exception to this is they are not called there's two exceptions. They are not called if we assign a value to a type in its declaration, or a value to a property in its declaration, and they are not called when the initializer assigns a value to a property in the declaration. Otherwise, they are going to be called every time that property is set. If we have a lazy stored property, it can't be assigned a property observer. You cannot have property observers on a lazy stored property. Think about it for a second and you'll figure that out. Now, will set and did set. Will set happens before the value is set. Did set happens after the value is set. Both of them get a constant parameter containing some value. Will set gets the value you're going to set it to, and did set gets the value you are changing from. In the case of will set, this parameter is named new value. By default, you can rename it. And in the case of did set, it's named old value, again, by default. If you want to rename it, you put the new value, the new name in parentheses around either will set or did set. So here we go. Let's look at an example. Here's an example called talkative number. Originally, I'd called this annoying number, but it has a variable. It's a structure. It has a variable parameter, the number, as an int equal 0. So it's being initialized. We don't have an initializer anyplace else, but we are initializing it here. And then a curly brace. We have two things, much like we would have in the case of get and set for computed properties. We have will set and did set. Will set says, hi, I was the old number, but now I'm the new number. And did set says, hi, it's so much nicer to be the new number than it was to be the old number. So if we set talkative number or an instance of talkative number, my talkative number dot the number equal 5, it will say, hi, I was 0, but now I'm 5. And then it will say, hi, it's so much nicer to be 5 than it was to be 0. So both of these sets of statements will be printed out. The will set happens immediately before the value changes from 0 to 5. The did set happens immediately after the value changes from 0 to 5.